Now we're going to do our last topic, and that is quadratic inequalities or nonlinear inequalities. So let's say you have y is greater than or equal to x squared plus 1. So first it's going to be very similar to inequalities when we had linear, meaning we're going to first graph it as if it was an equal sign. So that's y equals x squared plus 1. And then you pick a test point that's not on the parabola. So we'll pick, I like picking 0, 0. It's nice and easy. And I get 0 is greater than or equal to 0 plus 1, which is not true. So therefore, I shade in everything on the other side of the parabola. And my cup is full. The first parabola, if I graph it, this is basically just y equals x squared. So I get a dotted line like this. I pick a test point. Now, I can't pick the origin because the parabola goes through the origin, but I pick a different test point, and we wind up shading in the inside. You could pick a test point. Now, for the other parabola, I could tell you right now is going to be an upside-down parabola, but I want to see if these parabolas intersect, and if so, where. Before I draw the rest of the graph, I want to see if these guys intersect and where they intersect. Well, if I just do a very quick sketch of the second parabola, just bring the 2x squared to the other side, I get y equals negative 2x squared plus 12. Well, clearly it's an upside-down parabola. If x is 0, y is 12. So that's right there. That's 12 right there. So clearly the parabolas are going to intersect. You can just see from the picture that they're going to intersect. But let's find exactly the point of intersection. And for that, we're going to need algebra. To find the exact point of intersection, I have to pretend that these are equal signs. So this becomes y equals x squared. And I'm going to take y equals x squared and plug it into the second equation. I can plug x squared in for that y, or I could plug y in to replace that entire x squared. I'll get the same answer either way. In fact, I'm going to do it both ways just to make a point. So I'm going to do 2x squared plus x squared equals 12 because I'm substituting that y is equal to x squared. So when I plug x squared in for y, I got x equals plus or minus 2. Let's see what happens, just for funsies, if I plug y for x squared. Well, instead of 2x squared plus y, I got 2y plus y. 3 equals 12, y equals 4. Well, you know what? I can see from the picture that these are my two answers. And I don't have to belabor this anymore by testing out the algebra like we did before. I could see right away. Yay for the picture. Oh, but the question is where do I shade the second parabola? Because that's going to be part of my solution. Well, now I can pick 0 as a test point, and I see 0 plus 0 is less than 12, so I will include the 0, because the second parabola doesn't go through the origin, so we're cool. And the solution is where these red lines and the purple lines intersect, which is kind of like this egg in the middle. Notice that the upside down parabola is solid because of the equal sign. The other parabola is dotted. So I'm going to just make this a little deeper. So the solution is this kind of like egg shaped where I have both shadings. And that is the answer to that. And we are done with Math 116. Yay!